Hello, welcome to my Tech Fun. I'm Igor and I have another 3D printer review for this video. And this is Artillery Sidewinder X2. And this box is sent to me by the Artillery company in exchange for a review. And this box is so big that I had to switch to the wider angle lens so it can fit into the screen. And what I really like with this company that instead of just publishing new types, they try to improve their existing models. And that's the case with X2 because I already tested the X1, the previous generation. This is not a new model, I mean it is almost 1 year old, but I will do my review now. I already tested the Genius Pro, which is the newer generation, but the smaller size, because the print volume of this printer is 300 by 300 millimeters in XY direction and 400 millimeters in Z direction. The temperature, we can heat up the nozzle up to 260 degrees Celsius, but it has the Teflon line hot end, so it is not recommended to go above to 40 degrees Celsius. But optionally, you can buy the extruder kit together with the hot end, which can be heated up to 300 degrees Celsius. I already mentioned this is not new model, so there are a lot of videos how to assemble or how to level this printer. I will do that part too, but some quicker version. Instead, I want to see how it prints. Okay, let's see what's in the box. This is speed up video of unboxing. I just want to show you that everything is nicely packed in this black foam and protected during the shipping. And this is the content of the box. So we have this base, which is actually very huge, and we have the completely Z-axis with assembled hot end extruder and X-axis, spool holder, power cable, some spare parts, tools, ribbon cable, and user manual, and that's it. And also I noticed the fan shroud fall down, and exactly the same problem I had with Genius Pro, so I have to glue this back here. First step is installing the XZ gantry, and I have to pay attention that I have to align these two plugs. And I'm locking its position with 2 screws from each side. Next is installing the spool holder, and this is also a big improvement compared to the previous version. And basically this was the first upgrade I did on X1. The other side could be a little bit more stable because it's not supported and we don't have space for the bolts. Alloy extrusion would be better here. Now I believe that this injection molded part is the only downgrade compared to the previous version, because there we have some alloy extrusion and then we can mount different spool holders if we need to, or for example there are designed a different tensioner for this timing belt on the back side, or maybe we want to mount some LED lights or similar. And I will secure this other side with a zip tie. Not perfect, but much better. And before I glue back this fan shroud, let's take a closer look. So not my favorite solution when the part cooling is only from the one side. I'm not sure, are there any 3D printed versions? Maybe you can help me out. From tools I'm missing the pliers, but also it would be good to include the metallic tweezers. Connecting the cables on 2 Z-axis stepper motors. And I think this is the other side of the filament sensor cable. Filament sensor, and now the power cable, but double check this switch if it is set correctly for the voltage of your country. Last important steps. Do not remove before finish assembly, where it's finished in maybe 15 minutes or less. And don't forget to check the tension on the timing belts and V-slot wheels, and if necessary use the provided open-end wrench to tighten a little bit the eccentric nuts. In my case, the tension was set correctly, so I don't have to change anything, but it is very good to check these things. On Y-axis, we have 3 eccentric nuts on the right side. On X-axis, it is from the bottom. And interesting, on the Z-axis, we can do the tightening with this bolt here. Everything is explained on this assembly step update. And there is one cable which we will not use because earlier here we had the Z limit switch, but now we have this auto leveling sensor, so we don't need it anymore. Now let's turn it on. And it's ready. Before I start with the first leveling, I want to check the moving of the axis. Tools, move, and 1 millimeter, okay, X. Working Y, working Z, moving. Quick overview of this printer. So it has a very big heated bed. This is some kind of carborundum glass which theoretically it should stick good the material to it, and when it cools down it should be easier to remove it. And what is very unique with this printer, that it is heated with AC power from the bottom. The result is that it will be heated very quickly to quite big temperature if necessary, but disadvantage is that this is fixed, we cannot remove it. So very common upgrade, actually I did it on my Genius Pro, is that I installed the magnetic base and the PEI sheet to this. The screen is okay, but it gives a feeling that it's a little bit outdated, so it could be a little bit bigger. And here we have connection for the smaller SD card, and also it can print directly from the USB disk. I already mentioned the part cooling is only from the front, from one side, and it has some gear ratio reduction. This means that it can provide quite a bit torque, and it uses these Vulcano nozzles. Another improvement compared to the previous version, that these ribbon cables are secured here with this clip. And these cables give much nicer cable management to this printer. And maybe a few things to mention on the back side. So we have two stepper motors on Z-axis and two lead screws. So this means that this X-Gen 3 is supported nicely from two sides. And these two lead screws stay synchronized even when it is powered off, thanks to this timing belt on the top of the printer. And a very nice improvement compared to the previous version is this cable here for the heating and thermistor of the bed. It is nicely bended, and I believe that this is much more durable, and now this printer is really ready to be a workhorse in those print farms. And it's time to level the bed, and I will just follow these instructions given in the user manual. And now I will start the leveling process, and first is to level it manually. With this I am making this surface parallel with the moving path of the nozzle. This is an important step because yes, it has the auto leveling sensor and it can compensate any inaccuracy in the bed leveling, but it is best it doesn't have to compensate anything at all. First I will compress the springs a little bit more. I'm preheating the nozzle to 150 and the bed to 50 degrees. Tools, level. And this is so-called assisted manual bed leveling, where it will do the homing first and then it will automatically move above the knob, and I have to place a paper between nozzle and the bed and rotate the knob until I get the perfect friction, and then it will move to the second, third and fourth point, and then I have to repeat until I get the perfect distance in all four corners. And now I have the same friction in all 5 corners, and with this now the bed surface is parallel with the moving path of the nozzle, and I can start now the automatic leveling. More auto level. And this is a time lapse of approximately 2 minutes. Very important, click on EEPROM save. And still with preheated bed and nozzle, let's again check the Z offset. More. Save to EEPROM, and it's ready for inserting the filament and printing. Preheating the nozzle to 200 degrees Celsius. And for the first print, I always choose something that was prepared by the manufacturer. Cube. There is no purge line, it immediately starts with the printing. I didn't have time to remove from the nozzle that extra filament. But the printing looks okay. It looks like it sticks to the bed. I hope not too good. In the meantime, let's see what can we do during the printing. We can pause or stop the printing if necessary. Change the temperature of the bed or of the nozzle. We can change the filament if necessary. Oh, looks like now I have to change the filament because I don't have the option to resume. Resume. Okay. More settings. Here you can enable or disable the LED, change the speed, printing speed, and the fan speed. And here we can adjust the baby steps if necessary. If you notice during the skirt or brim that it is too far or too close, you can adjust that with these 2 arrows. Printing was finished a few seconds ago. Bed adhesion check. It looks like it is great. Okay, I think it will be good because the skirt came down very easily. So I'll wait until it cools down and then I'll try to remove it. The bed is approximately 35 degrees Celsius. Let's try now. Oh, great. Okay, the quality of this cube is promising, but now let's prepare the slicer and print some ONG code. Manage printers, add new printer, non-network printer, searching for the artillery company, and here is a Sidewinder X1. I'm just renaming it because nothing else will be changed here. The dimensions are equal. Inserting a Benchy, and with the different settings I'm slicing the G-code. And now let's print that Benchy. Okay, the first layer is good. The printing is finished. Oh. Okay, the bed adhesion could be a little bit stronger. And from the first layer I could see that I could go lower actually, but I don't understand, so what is the difference between this print? Because here the adhesion and the first layer was good. But anyway, I will lower it, so I hope I will get a better bed adhesion. Otherwise, this bench is great. I mean, great overhang, bridging, absolutely no stringing. It's a little bit hard to read the full names because only first 10 characters is visible, but when I select the file, then I can see the full name, and if it is correct, then I can confirm. Of course, this is speed up video of printing the first layer. With this printing, I want to check the bed leveling because I'm using the maximal bed surface, well, at least diagonally. And actually, I need this object. This is the ISO holder for the hammer. I already have one, but it is from 2 pieces, and now I want to print it from 1 piece. A perfect first layer. The bed is at 37 degrees Celsius, but I heard some cracks, so probably it cooled down and it shrinks, so it should be easy. Perfect. Finally, it is night and everybody is sleeping, so I can measure the noise from exactly 50 centimeters, which is half meters. Looking the numbers, the Genius Pro is a quieter, but this is also a very quiet machine. And I will add this information to my summary table on the website. I want to record the time lapse of the bed heating. According to the printer, the bed is heated up to 60 degrees Celsius, which is correct, but only on this part here. We still have those big cold spots, which are so far 20 degrees colder, but it will be equal after maybe 10 minutes. After 3 hours of printing, let's see the temperatures of the bed. The hottest is 62 degrees Celsius approximately, and the coldest spot is 51.2, so more than 10 degrees Celsius between hottest and the coldest spots on this heat bed. And now let's print something in the vase mode, something big. Preheating the nozzle for unloading the filament. Removing the filament, always push down a little bit, and then you can pull it out. Desktop trash can. With this printing, I want to check several things. One of them is again the bed leveling, which is great. This is still the first layer. The second thing I want to check is everything okay with the printing in a spiral or raise mode, because sometimes that power loss function may interrupt the smooth moving of the pad. And the third thing I want to check, is the maximal Z height, but I reduced this because even now it will be 10 hours printing and I will use 200 grams of filament, and I'm printing the trash can, which is designed by Brian from BV3D. Well, actually there is a fourth thing I want to check with this printing, and that's the power consumption. So I want to see this approximately 10 hours of printing, how much kilowatt hours will it use. After 4.5 hours, and it looks great. After 7 hours, the Z coordinate is on 200 millimeters. And I will not print at 400 millimeters, but I can see maybe there will be a problem if I print something so wide, because there will be a very big angle on this filament when it goes out from the sensor. But to print something big and this wide, you will need at least 24 hours, but I think several days. Printed in 9 hours and 8 minutes, and the power consumption was 0.8 kilowatt hours. And this is not even the maximal Z height, because approximately 10 more centimeters could go higher, but pay attention to this bending of the filament in that case. It's completely cooled down and I can see it's already detached. And quality of the surface is absolutely great. There are no problems with that spiral vase mode printing. And always with direct drive extruder, I always like to test how it prints flexible filaments. And this is TPU90, very soft flexible filament by Polymaker. Print doorstop. Okay. That will be a perfect first layer. These are doorstops, two types. One is the most popular from Thingiverse and the other from Printables. And I want to compare them side by side, which one is better. They have the same dimensions, 60 millimeters length, and it will be 20 millimeters in thickness. This is nice printing with very minimal stringing, interesting. Let's check the adhesion. Perfect. Well, from these two, this is better design. The conclusions. Even without this testing, I know that this is a great printer. It is a member of those print farms with a reason. It is a really good workhorse. This is now 1 year old model almost, and I got it only now for the testing. So this video is a little bit different, so I don't go into details of the structure of this printer. But as I mentioned, it is a great printer. I really like the possibility of printing from USB. It is super quiet, a great big print volume. Also nice direct drive extruder, great cable management. So this is what I like with Artillery, that instead of just creating a new models, they are improving their existing versions. And I will have some few suggestions for X3 version. First of all, I would like to see back that alloy extrusion on the top of this printer. Second, I really don't like this fan shroud. I mean, it gets the part cooling only from one side and it is glued to this fan. I would like to replace it with some 3D printed version maybe, which will partly cool the object from two sides, but well, now I have to remove somehow this one because I have to glue the printed version. Usually I saw that these fan shrouds are somehow screwed to some holder. And my biggest issue with this printer is this glass bed. It is great that it is from the bottom heated directly with the AC power, which is super fast and works great. But first of all, this glass is not removable, so I have to wait until it's completely cooled down to have some possibility to remove the object. Very often I see a lot of users of this printer, also I did that with Genius Pro, that I glue the magnetic base to this glass, and on that I can place the steel sheet with the PEI sheet on it. And with this I can have that removable version. Of course I added a lot of weight to the movable part, but for me the flexible sheet is very important. And also what I didn't like with this version, that if I heat it up to 60 degrees Celsius, I have more than 10 degrees difference between hottest and coldest spots. The coldest spots are usually above these knobs. And imagine you print some kind of box which corners are on those cold spots, and well, in that case there is a danger that it will warp, especially if you print on some higher temperatures, PETG or ABS for example. By placing that steel sheet on the top, I measure that actually this is additional layer. It takes maybe 10 or 15 seconds more until it's heated up, but the heat is spread more equally. Those are my suggestions for the improvement of this great printer actually. If you have some other comments, drop me a few lines down in the comment section. Thank you for watching and happy printing!